In Trig Identities Part 2, I'm going to look at a question that a student brought to me last week. It had been on a test, and a lot of the students in the class had trouble with this because it's not immediately obvious what you can do with either side here. Now, what I'd suggest is if you've got one side as a fraction, you can always multiply the other side, thinking of sine x plus cos x as a fraction, put it over 1, and you can multiply the top and the bottom by whatever you want, because that gives you an equivalent fraction. That gives you a denominator the same as over here. And if you multiply out the top, you need to do first times first and outer and so on. That's going to give you these three terms, and the sine squared plus the cos squared gives you a 1. So you can write it this way, just putting a 1 on the front. And you've got it the same as you've got over here. Now, if you don't like introducing something like this, your other option would have been to take this 1 on this side and rewrite it as sine squared plus cos squared, placing the sine squared here and the cos squared there. Then it's of the form a squared plus 2ab plus b squared, which is a perfect square. And that can be written this way: sine x plus cos x times sine x plus cos x. And then you can cancel off one of these factors, top and bottom, and that results in the right side. So you can approach this either way, but I find it handy whenever I've got a denominator over here to introduce that same denominator to the other side. Now, in this identity, we've got a 1 on the right hand side, so there's not really much we can do with that. If that was a plus sign, this could be factored, but the way it is here, there's no way of factoring that. However, if you move the cos to the fourth and put it over here, you've got a difference, actually a difference of squares. I know it's fourth power, but it can be treated as a difference of squares, which can be factored like this. Once I factor that, this bracket is simply a 1 because it's sine squared plus cos squared. So it's 1 times this, which results in just sine squared minus cos squared, plus the 2 squared, and when you add these two together, take the cos squared from 2 cos squared, we've got sine squared plus cos squared, which again equals 1. So that sine squared plus cos squared equals 1 shows up quite a bit in these identities. Here's another one. What I decided to do with this one, I took the left hand side and I rewrote the tan as sine over cos, and the secant is 1 over cos. Now that gives me a common denominator, so I can write it like this with just that common denominator right here. Now, when you square a fraction, you square the top and you square the bottom of the fraction. Now, if you always keep an eye on this side, you see we've got this factor over here. So I want to keep that. I don't want to expand that because I need that factor to get this. But the cos squared can be replaced with 1 minus sine squared. And that's a difference of squares. Again, we've got a difference of squares here. You can factor that into 1 minus sine, 1 plus sine, and cancel this factor off with one of the ones on top, and that results in what we've got on the right side. Finally, here's one more. Looks a little strange. Tan squared plus cos squared equals plus 7. The 7 here is a little strange, but you'll see where that comes from on the other side. What I'm going to do here is I'm going to expand these. It's like a plus b squared. Same thing there. Now when you do that, you get a lot of stuff here. Sine times sine is the sine squared, then you've got the 2 middle terms, and the cosecant squared. Same thing over there. When you expand that, this is what you're going to get. Now, sine times cosecant. Cosecant is 1 over sine, and if you want to write that in your next line, you can do that. But basically what happens when you multiply an expression times its reciprocal, you get a 1. So what happens is, right here we pick up a 2 because it's sine times 1 over sine, and over here we also pick up a 2 because it's cos times 1 over cos. So I'm going to add the two 2's together. That's where I got the 4. I'm going to move that cos squared over here with the sine squared, because once again sine squared plus cos squared is another 1. I can add those together and I've got this. Now I said at the beginning of the first video on identities that I always try to use sine squared plus cos squared equals 1. However, in a case like this, where I've got the cosecant squared and the secant squared showing up, that's one case where I'm going to give in and use these substitutions for secant squared and for cosecant squared. And that's where we get the 7, the 1 plus 1 and the 5. So there are times, I must admit, that knowing these other two are an advantage. If I didn't know those, going from here to there would have taken me a lot more work.